In this video, we're going to look at calculating the volume of different solids. And when we calculate the volume for different solids, we're just going to basically use a formula, and for the OAA they give you a formula sheet or reference sheet that has a lot of these different formulas that I'm going to use to find the volumes of these examples in this video. Here we've got a rectangular prism, and the volume that they give us, so we got a rectangular prism. The volume they give us for a rectangular prism on the reference sheet for the OAA is volume equals length times width times height. So if we do this, all we gotta do is identify those in the drawing and plug them in. We've got 15m times 6m times 2m. And when you do that, and you end up with 180 when you multiply the numbers together, and it's going to be meters cubed. Volume is always in cubic units. In this video, we're going to calculate the volume of the right prism. And on the formula sheet for the OAA for a right prism, they give us this formula. Volume equals capital B times H. And this capital B represents the area of the base. So in this problem, we're going to calculate the area of the base and multiply that by the height of it. So if we've got this formula, and if we look at the base, here the base is this triangle. So the formula for finding the area of a triangle is 1/2 base times height. I'm going to plug that in for capital B, and we got to multiply it by the height of the prism. So the base of the triangle is 7 meters. The height of the triangle is 6 meters. The height of the prism is 11 meters. When we multiply that all together, we get 231, and the units are always cubed, so meters cubed. Alright, here we're finding the volume of another right prism, and the formula is the same one we just used. So volume is the area of the base times the height. And if you look at the base in this particular one, because the bases of prisms are the parallel and congruent sides, it's a trapezoid. So we're going to plug in the area for the formula for the area of a trapezoid, and we got to multiply that by the height of the prism. So if you look at just the trapezoid, the height of the trapezoid is 4 centimeters. The one of the bases is 8. Add the other base, which is 6, and we have to multiply this by the height of the prism. So half of 4 is 2 centimeters. 8 plus 6 is 14, and we're multiplying that by the 4. And that gives us 112 cubic centimeters, or centimeters cubed. Alright, in this example we're asked to find the volume of the cylinder, and on the reference sheet they give us the formula for a cylinder to be, for volume, pi times r squared times height. So if we plug those values in, well, pi is about 3.14. The radius in this one is 3 feet. Square that and multiply it by the height of the cylinder, which is 7 feet. And this is approximately 197.82 feet cubed. Alright, now we're going to find the volume of the pyramid. The formula they give us on the OAA reference sheet is the volume is 1/3 capital B times height, where capital B represents the area of the base. And on here, the area of the base is a rectangle. So when I rewrite the formula, I'm going to plug in length times width. That's how you find the area of a rectangle. I'm going to plug that in for capital B and multiply it by the height of the pyramid. So we have 1/3, and then in parentheses here we got 8 feet times 6 feet. And I multiply that by the height of the pyramid, which is 8 feet. And then this gives us 128 feet cubed, or cubic feet. Alright, so now we're looking at the last example here, and it's to find the volume of a cone. On the OA reference sheet, it gives you that the formula for finding the volume of the cone is 1/3 times pi times r squared times the height of the cone. So when you plug this in, we've got 1/3 times 3.14 times the radius squared, the radius is 10, times the height of the cone, which is 20 centimeters. When you calculate this, we get approximately 20,093.33 in centimeters with volume, cubic. I'm always measuring cubic units.